Well, here we are. We're about to use some data to give some future information on world population using a least squares line from a calculator or computer software. I'm going to use computer software, so I hope you find it interesting.
I can't wait.
I'm glad. So here's my data. In 1960, the Earth's population was 3 billion. 1970 it was 3.7 billion, 1980 4.5 billion, 1990 5.3 billion, and 1996 5.8 billion. So actually I'm defining two vectors. This is the way my software works. Two vectors, one for the x values, one for the y values, and then I can just say line and use those two vectors, and it will give me the line of best fit. This gives me the b, which is the y-intercept first, and then the a, which is the slope second. By the way, this is saying that the slope per year is almost 7%, so that's a huge increase in world population. So So that is our least squares regression line. I didn't use it to predict a population, but we could use it to predict the population in 2010, which I'm going to do later. This is how my software does regression and gives a second degree equation. And it gives me this information. So this is the squared terms coefficient. This is the linear coefficient, this is the constant coefficient, and here's my best shot at the graph. I've got the quadratic in red, the dotted is the least squares line, and the purple dots is the data that I used. Okay. In the year 2010, that would be x equals 50. We'll have approximately 6.866 billion people on Earth, and the quadratic model gives us 7.04777 in 2010, so I think actually it might be a little bit closer to the quadratic model, or maybe in between the two. And actually I didn't choose the best model. Probably the best model would have been exponential growth. So I hope you found that interesting.
I can't take this!
Well, sorry.